Now we are going to solve equations of the form sine for n theta plus alpha equals k, or cosine for n theta plus alpha equals k, where k is between -1 and 1, or tan for n theta plus alpha equals p, where p is a real number. In this tutorial, we will take the form cosine for n theta plus alpha equals k. Look at the description. We can replace the value n theta plus alpha, which is found in all the trigonometric ratios, by x, so that the equation reduces to the type we have solved previously. In other words, we forget that we have n theta plus alpha. We substitute it with x, thus the form will be sine x equals to k, which we already worked with previously. You must be careful to ensure that you give all the solutions in the given interval. We are going to solve example number 10. Solve the equation cosine 3 theta degrees equals 0.766 in the interval where theta is between 0 and 360 degrees. First of all, we have the equation cosine 3 theta degrees equals 0.766. where theta is between 0 and 360 degrees. We say, let x be 3 theta. Thus, cosine x is 0.766. And since theta is between 0 and 360 degrees, then we multiply the intervals of x by 3. So 0 times 3, theta times 3, and 360 times 3. X is between 0 and 1080 degrees. Now we define the new range for the new angle for cosine x equals 0.766. We will calculate the value of x using the calculator. It is cosine -1 for 0.766. As usual, you need to be sure that the angle is in degrees. Shift cosine 0.766 equals 40, so 40 degrees. This is the first measure of the angle. Now, we look at the quadrant plane to find the second angle. We want the cosine to be positive. Here, the cosine is greater than 0, so in the first quadrant and in the fourth quadrant. These are the angles. Here we have 40 degrees and here we have 40 degrees. The first angle is exactly equal to 40 degrees, while the second angle is 360 minus 40 degrees, so it is 320 degrees. These are the two solutions. Pay attention, the range of x is not between 0 and 360 degrees. It is between 0 and 1080 degrees. That means there are other rotations on the quadrant where cosine equals 0.766. Now we need to find the other solutions. Remember that the period of the cosine is 360 degrees. So we add multiples of 360 degrees for each measure of this angle. So 40 plus 360 degrees, it is 400 degrees. Then we have 320 plus 360. The answer is 680 degrees. You are simply adding 360 for each angle. We are still less than 1080. So we need to add 360 degrees to the 400 degrees. It is 760 degrees. We also add 360 to the 680. It is 1040 degrees. Now we stop, because if we add 360 plus 760, then it will be greater than 1080. These are the major angles. Pay attention that we need to find theta, not x. So we go back to the initial equation, x equals 3 theta. So we write, but x equals 3 theta. So to find theta, we divide x by 3. So in order to find theta, we divide each value of x by 3. 40 divided by 3 is 13.3, comma. 320 divided by 3 is 106.7, but we want up to 3 significant figures, so 107. 400 divided by 3, it is 133. 680 divided by 3 is 227. 760 divided by 3 is 253. And finally, 1040 divided by 3 is 347 degrees. All these angles satisfy the condition that theta is between 0 and 360 degrees. You need to pay attention that we did the additions of the multiples of 360 degrees. Look at the book. Let x equal 3 theta, then we replace 3 theta by x and we solve. Before solving, we change the interval of x. The value of x from your calculator is 40. We need to list all values in the first and the fourth quadrants for 3 complete revolutions, as if the angle is rotating 3 times, since x is 3 times theta. And we need to remember that x equals 3 theta in order to divide by 3 when we want to find theta. Always check that all of your solutions are in the given interval.